Whenever we are uh, making a measurement, reporting a value, we must include two things. The first one is the actual number of the value or the measurement that we took, and the second one is the units. Any number that you report without any units becomes meaningless. Try to think of, let's say, your salary. Are you making 10 an hour? 10 what? $10, 10 million, 10 cents, right? The unit becomes really important because it gives context to your values. There's a set of units that we tend to use regularly, more by convention than anything else, to report certain values. We have what we call the metric system, and in the metric system there are certain units that are standard. For instance, if I'm measuring length, I'm going to be using the meter in the metric system, which is slightly different from the system that we tend to use, which is in feet and in inches, right? In the metric system, we use meters instead. For mass, we tend to use grams, liters for volume, and time is usually reported in seconds. If we want to represent really big numbers or really small numbers, then we usually attach a prefix to our units. Let's say, for instance, that I want to report 1/1,000,000th of a second, or a meter, or a liter. I will use the prefix nano right here at the bottom. So, in the case of a meter, I will use the nanometer, the letter N followed by the letter M for the meter, and that will represent 1/1,000,000th. We also have what we call the scientific notation. We'll get into more details in a later class, but here I just wanted to show you that it translates really big or really small numbers into a shorthand notation. Look at the nano example, for instance. If you look at the decimal place right here, you want to put that decimal place right after your first non-zero number, you would have to move it 9 places to the right. In scientific notation, that translates to 1 times 10 to the minus 9. The same is true for really big numbers. If you look at the top end of that table, we have the giga prefix. Think of your USB drives, for instance. They have gigabytes. That means that they have billions of those bytes, which are units of storage, right? In this case, if you look at the decimal place right here, you'd have to move it 9 times so that it's right next to your first non-zero number. Because you moved it 9 times to the left, then it will be 1 times 10 to the positive 9. As you can see, we're just breaking down what we just saw in the chart. We have the length, we use meters. If you want to represent 1,000 meters, we use kilo, 10 to the 3, or thousandths. 1 kilometer represents 1,000 meters. That makes it much more convenient to represent big or small numbers. Let's say, for instance, I want to measure the distance between here in Anchorage to, let's say, Shreveport. I can use, instead of thousands of meters, I will use kilometers. Commonly here in the States, we will use miles, which is a little bit more common. But for the metric system, kilometers is the way to go. Very small numbers can use millimeters or even centimeters. This can be said in two ways, and once we get to conversions, it's going to make a little bit more sense. But I can say that 1 millimeter is 1/1000th of a meter. Or I can also say that in 1 meter, I have 1,000 milliliters. For mass, we use the unit of grams, like we saw before, right? And it's very important that we distinguish between what we call mass and what we call weight. Mass is nothing more than a measurement of how much more matter something has. Weight involves gravity, how much force that matter feels due to gravity. So that means that on different planets, you will have exactly the same mass, but you will weigh differently. In the case of volume, we tend to use the liter. We can also use it in terms of, let's say, change the unit a little bit, in terms of length. We can use length in all 3 dimensions, length times width times height, and that will give us centimeters or meters cubed, elevated to the power of 3. In the case of cubic centimeters, there's a 1-to-1 translation between cubic centimeters and milliliters, and that's what we call the cc's. 1 cc would equal 1 milliliter. And lastly, just a brief summary of the metric system and the English system, which is the one that we're more used to, and just some conversions. For instance, you would have for length, you can use yards, miles, or feet. You have them right here, and we see how they interconvert with one another. For mass, we tend to use pounds and ounces, or even tons, and we see how they translate. And for volumes, especially those of us that like to cook, we have pints, we have cups, we have quarts, and we have fluid ounces, and we see how they convert with one another. And that's it for measurements up to this point.